Hi, everybody. This is Mr. McRitchie. I am here to walk mostly my students through, but if anyone else here is watching this to sort of help them review for the AP exam, a bunch of questions from a practice that I created involving the money multiplier and bank balance sheets, as well as some Fisher equation. This is basically the Unit 4 math stuff. The practice will be linked in the description of this YouTube video, so any of you guys who aren't in my class can still open it, and it's on Google Drive. You can just make a copy of it. If you wanted to, at this moment, pause this video, open that practice, and maybe try to solve it yourself, or pause before I answer these problems and try to solve them yourself, feel free to work along, as the best way to get better at this stuff is to practice it yourself. This is just me walking my kids through how they should have solved this because I was gone from work the days that we learned this material and did this practice. I was out sick. So here we go. Let me open up the practice for you. All right. So Fisher effect, Fisher equation is what I should say, money multiplier and bank balance sheet practice. Okay. Fisher effect first. So the Fisher effect is, any of you guys that don't know, the basic idea, I'll just sort of type this here. The Fisher effect is the idea that the nominal interest rate, let me remove the bold and underline here, that if you take the nominal interest rate, which is the interest rate you literally agree upon, like with a bank, for a loan or on your savings account, like if you look at your savings account and it says like a 0.2% interest rate, that is the nominal, it's regular interest rate. And you subtract the inflation rate from that number, that will give you what we call the real interest rate. The real interest rate is like how much you're paying back, if it's a loan, like how much you're paying back in addition to what you borrowed in value. Like you borrow $20,000 to buy a car, you have a 5% interest rate, you'll pay back 5% of actual cash. But because money loses spending power over time due to inflation, the cash you're paying back might not buy the bank 5% more worth of stuff, might only buy them back 2%, 3% more of stuff. Like how we mentioned back in Unit 2, that if you got a 5% pay raise, but there was 2% inflation, your real wages grew by 3%. Same idea here, just for interest rates. So assume the nominal interest rate is 10%. If the expected inflation rate is 5%, the real interest rate is, okay, this one is a simple plug and chug. There's no complicating factors here. Nominal interest rate is 10, so that's 10, and this first number will be 10, minus the inflation rate is 5. It's usually expected because it's usually what they predict the inflation to be, because the bank is thinking how much inflation is going to happen, so how much are we really going to get paid back? The real interest rate would also be 5%, because you would just do 10 minus 5 is 5 to find that. Nominal interest rate minus inflation rate equals real interest rate. The way I always remember this formula, same way I remembered it back in Unit 2, the difference between nominal and real values is inflation. That's like the difference terminology-wise. Real adjusts for inflation, nominal doesn't. And in second grade math word problems, difference means subtraction. So you just do nominal minus inflation equals real. Okay, 2. The annual inflation rate is expected to be 5%. Juan plans to take out a loan to purchase an automobile. Okay. If Juan decides not to take out the loan if the real interest rate exceeds 3%, the highest nominal interest rate he is willing to pay is blank. Okay, so numbers that I've given. This is always how I solve these problems. What was I given? Inflation rate, 5%. Got it. Thank you. The does not want to take out a loan if the real interest rate exceeds 3%. So he doesn't want the real interest rate to be more than 3%. It could be 3%. He doesn't want it to be more than 3%. The highest nominal interest rate that he is willing to pay is what? So it's asking me for the nominal. So I'm looking at that formula. I'm not solving for either of these guys. I'm actually solving for this first number. So a little bit of algebra. Inflation rate should be 5%. Okay, so that's going to be 5 again. Great. Doesn't want the real to be greater than 3. That's what's the highest nominal interest rate. So the highest nominal would be whichever one gets us to 3. So 5, 3, question mark. What minus 5 is 3? Which we just simple algebra here. That would be 8. Oh, that's my dog hiccuping. Thank you, bud. I will show dog after a few questions. It's a bit early here. So 8% would be our answer here, because the highest nominal interest rate he would be willing to pay is whichever one would get him to 3%. He'd obviously be willing to take out a cheaper loan than this. This is just saying like worst case scenario. If he knows the inflation rate is going to be about 5%, then the highest nominal rate he'd be able to take out is 8%. Obviously, you want your loan to be as cheap as possible. So this is kind of, say, unnecessary, but like worth mentioning. He'd love to take it out at like 0%, but highest he'd be willing to pay is 8. So that's the Fisher equation problems right there. That's just a quick little run through of Fisher equation. It's most of the math in this class is, if you know the formula, you've got 90% of the work done. From there, read through the question, mark the stuff they give you. What do they give me? Inflation rate, 5%. Cool, I'm just gonna write that off the side. Real interest rate exceeds 3%. Okay, so I'll put 3 there, sort of. I'll be like, let me see if that exceeds matters. It says the highest element rate, so the exceed kind of doesn't matter based on the formula, but I put the 3 there. Worst case scenario is you don't really know what the exceed or highest part is, and you just kind of ignore those words. In this question, that actually would have worked out just fine. Okay, time for the fun part, the money multiplier. So, as I explained in class, and if you watch the video over the balance sheets, this is also explained. The idea is that banks can loan out money multiple times over and therefore create money that is spendable in the economy. It doesn't physically exist, not printed at all, but it is numbers on a computer that you have access to. It's a weird way the banking system is able to actually artificially inflate the money supply, but it does allow for more spending. So the keywords here that I mentioned are the required reserves, which is the amount of money the banks are holding on to maintain the reserve requirement. So if the reserve requirement is 10%, then this would be 10% of deposits would be the required reserves. And the excess reserves is the amount of money the banks can use after taking away the required reserves. So if that reserve requirement is 10%, the excess reserves would be everything else, the 90%. So think of, again, I mentioned in class, think of your deposit as being split into 2 chunks, excess and required. Now these make up total reserves, but excess, required, normally 90-10, but the questions here, as you'll see, use different reserve requirements just to make sure you understand the concept and fractions and stuff like that. Okay, number 3, the reserve requirement is 20%, okay, pretty high. Banks currently have 50,000 in total reserves. Hello, important word here. That's total reserves. Reserve requirement is 20%. That's pretty easy to keep tabs on. How much money can be created through the lending process? The formula for how we're using the money multiplier in most of these problems is you take the change in the excess reserves, translation, how much money the bank can loan out. You multiply it by the money multiplier, which I'll give you the formula for in a second. And that gets you the change in the money supply, how much money the banks can create. Whenever they're asking how much money can be created, they're asking the change in the money supply. That's just another way of saying those words. Okay, so how much excess reserves they've got that they're going to loan out times the money multiplier. That money multiplier, can't type, is 1 divided by the reserve requirement. And that's what we need. So these 2 formulas are what we're going to use for a good chunk of the rest of this, including the bank balance sheet. These are the formulas you really need to have down for Unit 4. These 2 in Fisher are all the math you need for Unit 4. It's just knowing what the question's asking for in this unit, especially when it comes to these 2 guys, is kind of tricky. So reserve requirements 20%, banks have 50,000 in total reserves, meaning excess and required combined. How much money can be created through the lending process? I'm going to assume that those total reserves are all the bank has, that they don't have anything else. Technically, the question should include a little more information saying like they have $50,000 in total reserves and that's it. They don't have they haven't loaned out any money yet or anything like that. But for the sake of this problem, we're just going to assume that this is the same as the deposit. They just haven't split it for us. So what I need to do first is figure out how much of those total reserves are excess versus required. And I'm going to use that 20% to do so. So I'll just do 50,000 and take 20% of that, which is, if you want to do the calculator for all of this, obviously, but I know the answer. 20% of 50,000 is 10,000 because 20% is a fifth, and a fifth of 50 is 10. So I know the required reserves is $10,000. I know the excess reserves, therefore, have to be 40,000, because again, I'm just splitting up this 50 into money they can't and money they can loan out. From there, I then get to use the multiplier formula to find the answer. So the first thing I have to do here is figure out how much in excess reserves we actually have, so that I can then do this change the money supply thing. The question's asking for change the money supply, but I can't solve that until I know the excess reserves. So I got to find that first. That's why the 40,000 is there. So I'm now doing 40,000 times 1 over 0.2. Careful, you got to convert percentage to decimal, equals blank. 1 over 0.2 is 5. 0.2 goes into 1 5 times. So 40,000 times 5, which is 200,000. That is our answer to this first one. 200,000 is our answer to this first one, because you just take the excess reserves times the money multiplier, gets you the change in the money supply. Cool. It says change in excess reserves. We're going to assume in pretty much all these problems, the bank is going to loan out all of their excess reserves, meaning, yeah, this is going to be like the largest possible number we can get here. Okay. So we're going to assume they're going to use all of the excess reserves here. Unless a question specifies something else, you just assume they're going to loan out all their excess reserves. Okay. 4, algebra. Lots of algebra with this stuff, by the way. It's kind of like Unit 2's math and Unit 3's math for the multiplier stuff. There's a lot of algebra used to find different parts of the equation. It says that banks have expanded the money supply by 100,000. Okay. Banks originally had 10,000 in their excess reserves. What was the reserve requirement? Okay, so they've done some algebra here. They've given me the change in the money supply. They've given me the excess reserves. It's asking for this. So, okay, it's 10,000 and 100,000. So I know the multiplier is 10, because 10,000 times 10 is 100,000. That part's easy. It does ask for the reserve requirement, so I have to do like 10 equals 1 over x to solve this, although thankfully, if you solve that out, which is just, you do like, multiply both sides by x if you want to do actual algebra, and then divide both sides by 10, that would work. It's 10%. Like algebra is how you would technically do this, although this one's a little more straightforward because the multiplier and the reserve requirement are the same. Because if you do 1 over 0.1, you do get 10. 1 over 0.2 is not 20. Careful. Doesn't always work like that. You would have to solve for the reserve requirement. The multiplier is the multiplier. The multiplier is equal to 1 over the reserve requirement. So you're finding this number and then using that number to find this number in the formula below. Careful for your thought process there. Some kids get the 10 as the multiplier and just have that as their answer. It's technically like you get lucky, but be careful. 10 and 10% are not numerically the same value. 10 is a lot bigger number than 10%. 10% is 0.10. So be careful. AP exam's tricky with percentages sometimes. If it's a percentage, you should make it clear that your answer is a percentage. Like 10 and 1/10 are not the same thing, right? Okay. So it's a bit of algebra there. 5. The reserve requirement is 10%. Banks have no excess reserves initially. Okay, so they're starting at 0. How much of a $50,000 deposit could they lend out initially? Okay, so this one's a little simpler. This one's not a multiplier problem. It doesn't ask how much money can be created because it's asking about initial. Be aware, the key words for these are usually initial versus over time. The multiplier effect takes place over a long period of time because money gets loaned out, deposited, loaned out, deposited, loaned out, deposited. That process can take some time to have happen. If it's just asking initially, it's just asking how much money the bank can literally loan out of that deposit. And I know that percentage-wise. Remember, reserve requirement's 10%. Okay, so I know the bank has to hold on to 10% of the deposit. Cool. We then have this $50,000 deposit, so I'm just in my head doing this little breakout. 50,000. Nope, don't want a number 6 there. Okay. Oh God, there we go. 50,000 times 0.10 would get me the required reserves, which is 5,000. So that's my required reserves, meaning the money the bank can't loan out. Remember, they have to hold on to 10% of that. So the rest of it, I could either do 50,000 times 0.9 or 50,000 minus 5,000. It's the same math concept there, so I'll just do subtraction because I don't need a calculator for that. It's 45,000, right? If of this $50,000 deposit, they have to hold on to 5,000, then they could loan out 45,000. It's asking how much the bank can lend out. That is synonymous with excess reserves. Those are the same thing. Those mean the same thing. Excess reserves is money the bank can loan out. So always be careful. Like your knowledge of vocabulary is just as important as knowing the formulas. So don't skip to formula. You don't get a formula sheet on the test. You don't get a formula sheet on the AP exam. You don't get a vocab sheet either. Know the vocab first. That'll help you with most of the problems because if they're asking how much money can be lent out, I know that means excess reserves. And it gave me the reserve requirement. So if the reserve requirement is 10%, the excess reserves would be 90%. So the math gets a lot easier the better understanding you have of vocabulary. I will always say, especially Unit 4 and Unit 2, because that one's got a lot of math. Definitions first. Do Quizlet, quiz your friends, do a vocab quiz, something. Make sure you know what all the terms mean. You know what the money multiplier is, not just number, but like what's the idea. You know what the reserve requirement means, not just what the number is, but what is that number telling me. You know what the required reserves are. They're not the same as the reserve requirement. It's the percentage is the reserve requirement. The actual money is the required reserves. And the excess reserves, what those are. It's very important to know the vocabulary in this unit. There's a lot of new words happening in Unit 4. You've really got to keep yourself in check there. If you're not in my class, I don't like to just do a vocab quiz in this unit. I don't because I don't love quizzes grade-wise. But if they're doing a vocab quiz in your class, trust me, they're justified. This is the unit where I would do it. If I was going to ever do them, I would do them in Unit 4 because it gets annoying. Okay, last one before we get to the balance sheets. This is all sort of helping you get used to stuff that'll happen on a balance sheet. Okay, assume Linda deposits in her checking account the $1,000 cash she was keeping at home for an emergency. Okay, so she deposits $1,000. Got it. If the required reserve ratio, which to be clear, the reserve requirement is a percentage, the required reserve ratio is a decimal, they mean the same thing. So this is the same as saying the reserve requirement is 20%, the required reserve ratio is 0.2. It's just a different way of phrasing the number. Same idea though. What is the maximum change in the money supply? That's what the question is actually asking for. So the good news is I know what I'm looking for. I know what formula to look at too. It wants to find this change in the money supply. Okay. Just like with the first problem, I need to know how much the excess reserves change by and the money multiplier. But I have enough information to figure that out. So of that $1,000 deposit, I know that 20% of it, or $200, are going to go to the required reserves. I know that the remaining $800 are going to go to the excess. And again, how do I know that? That is just because of that reserve ratio right there. This is 0.2, meaning the reserve requirement is 20%. So 20% of 1,000 has to be held, can't be loaned out. That's this 200. The remainder, the leftovers, that's why it's called excess. Excess always means like leftover. So this excess right here, that is our leftover money, money that can be loaned out. So I know that's 800. Cool. I know the first part of the equation. I know the money multiplier, cannot type, equals 1 over the reserve requirement. So 1 over 0.2, which, oh, look, what's so cool, Google form. Thank you, Google Doc, for doing the math for me. Yeah, 1 over 0.2 is 5. That's right. So I now can use the actual formula. It's the excess reserves, and assuming that it says their maximum change in the money supply, meaning if they were to loan out every dollar possible, so all 800 times my 1 over 0.2, 5, gets me the answer, 4,000 should be, unless I'm bad at math. $4,000 should be our final answer here. Boom, ta-da! Yay. So these problems, not necessarily that hard. These would all fall under what I would call multiple choice question possibilities on the AP exam, because you could just throw a bunch of numbers as multiple choice answers here and have these all be answers, because all you've got to know is what you're actually looking for and what equation you're actually using. The good news is there's only 2 equations I was using. There was these 2 right here. Change in excess reserves times money multiplier equals change in the money supply, and money multiplier equals 1 over reserve requirement. Technically, you also have to like logic out the deposit split, but that's not really an equation. That's just a logical understanding of deposit, percentage goes to required reserves, percentage goes to excess reserves. Now time for the fun part, the balance sheet problem. So feel free to pause the video here, take a look at this question. If you haven't solved it yet, try to solve it, especially if you weren't sure how to do the multiplier stuff, so you got very scared by this. For sure, pause, try to do this. It's tricky because B and C you might not understand, but give it a sec to actually try to solve it. Just pause the video. I'll go over in a second. Okay, unpause the video now. All right, so the 2 rules are both sides, assets and liabilities, must equal one another. This is an accounting rule. Basically, In case you don't understand it, the liabilities is the money the bank has, money that's been given to the bank, like your deposit. The assets are things the bank is making money with that money. Like what they're choosing to do with this right side is here on the left. They have $25,000. They are using it this way. They have loaned out 1,000 of it. They currently have 1,000 of it in their excess reserves. They have 500 of it in our required reserves. That's the information that I know based off this table. Okay. First question was the required reserve ratio. This is technically the decimal, but on the AP exam, they have historically been cool with you writing it as a percentage or decimal. Haven't seemed to care. So if you want to be technical about it, this should be a decimal. But if you wrote it as a percentage, those numbers are the same thing. So I wouldn't care here. Basically, that's what the reserve requirement is. The way you would tell that is comparing these two. The required reserves to the deposits. Reminder, the reserve requirement is the percentage of deposits banks have to hold in their required reserves. So technically speaking, what I'm doing here is 500 divided by 2,500. Trying to find that as a percentage, which if I solve it like this would get me that percentage. But basically, what is that in percentage form? The answer there, that is a fifth. I know that from ignoring all the zeros. 5 over 25 simplifies to a fifth, and a fifth as a percentage is 20%. If I wanted to, yeah, because I could write it as a fifth or 0.2 or 20%. They prefer the reserve requirement and reserve ratio to be written as percentages, or decimal would be also accepted. They don't like it as a fraction. I don't think they would take off points if you wrote it as a fraction, but you should get in the habit of writing it as a decimal percentage because that's how you will always see it in questions. So if you're a person who's good at fraction to decimal to percentage, this is easy for you. I'm really good at that, obviously. That's the kind of my wheelhouse for things. But you get a calculator on the AP exam, so don't get too scared if you're like, whoa, I don't know what this is. It's like, it's cool. It's not technically a math test in terms of your math skill. It's a math test in terms of you knowing what math to do. Different things. Knowing what math to do is a memorization skill, not a mathematics skill. So even if you're a person who's like, I'm more of a history kid, it's like most of your questions in history are you memorizing things. Like you needing to memorize dates of events and what happened at like Baker's Rebellion or anything like that. Like it's a lot of stuff like that. So this is the same kind of thing. It's just I have to know where to put the numbers. Okay, B and C is where this gets funky. So you're gonna have to strap in for this part. Assume Wanda withdraws $500 from her bank account at Sarkovia Bank. If you're wondering, I am a nerd. This is a Marvel reference. Wanda withdraws $500 from her bank account at Sarkovia Bank. What will the new excess reserves equal? This is a balance sheet problem. So here's how you do this. They're taking $500 out from the excess reserves. Okay. Well, they're withdrawing $500 from her bank account. Sorry, the deposits drop down to $2,000. But this is what they're doing with this. So if there's $2,000 on this right side, the $500 also has to come from here because this person withdrew $500 from the bank. So yes, it's $500 less in deposit, but the $500 also comes from here somewhere. Where should it come from is the first question you should ask yourself. I know it can't come from this loan number because that money is not at the bank anymore. It's loaned out. The bank's not going to call back whoever they loan the money to if they can help it. So it's not going to come from there. I know the excess reserves is money the bank can like freely use. So I'm going to use that because that's money the bank can loan out, give out, do whatever they need to with. I'm going to make it come from here. So I've got 500, 500, 1,000, 2,000. First rule, set. Second rule, the reserve requirement must hold true. The required reserves have to be that correct percentage of deposits. That's what's wrong right now. This question is not solved because I haven't done this second step here, which is this number right here needs to be 20% of this 2,000. This percentage is not changing. This percentage is the rule they have to follow. So here's what's going to happen. I need to find 20% of 2,000. So I'm going to do that really quickly. 20% of 2,000, a fifth of 2,000 is 400. So this required reserves here doesn't stay 500. The $500 that was here, 400 of it has to stay and still be required reserves, still be held on to, can't be touched because this is 20% of this. But the 100 that was left over now gets added to the excess. So here's what I did. I took the deposit out of the excess reserves first because that's money the bank can not have to worry about. I then adjusted the required reserves to match the demand deposits. Whatever money was left over there, leftover equals excess. I added to my excess reserves. I can't touch this loan money because this money is loaned out already. This owner's equity is money the owner of the bank has put into the bank. It's not a deposit, it's more of an investment. It's money the bank can use, but it's not money the bank is liable for, really, or has to, but they're liable for it. They don't have to like hold on to any of it. They can use it all. And it's also $0, so I don't have to worry about this problem. I checked the two rules again. Assets, liabilities equal each other. 2,000 total on this side, 2,000 total on this side. Reserve requirement must still hold true. 400 is 20% of 2,000. True. So her new excess reserves now equal $600. That's our answer there. There's no work I can really show there that doesn't involve me just like scratching numbers out of the table, basically. Like on paper, I would be like, cross out the 1,000, make it 500, cross out the 2,500, make it 2,000. I like doing balance sheets on paper, which if this is an FRQ, so if this was on your AP exam, you would be able to do it on paper. You could just copy down the balance sheet, or the balance sheet will be printed off on the question. You can scratch it. If they ask you to show work for this, then I would copy the balance sheet and literally scratch out stuff. I don't think they would ask you to show work there, though. C, after the withdrawal, how much money can Sarkovia Bank lend out? Okay, it's asking how much money the bank can loan out. Let's be careful about terminology here, because phrasing of these is where kids get messed up the most. This $1,000, is this money the bank can loan out? The answer is no. It's already been lent out. That money, gone. Not at the bank anymore. They've already lent it out. Some guy named Jeremy came and got a $1,000 loan, and the money's no longer at the bank. The bank can't loan out that money until it gets deposited. So for now, that $1,000 is off the table. What number in this table here is money that the bank can loan out? What number is it? Hello. It's excess reserves. B and C are the same question. $600. Excess reserves equals how much money can be loaned out. Maximum change over time of money being created via loans is money multiplier stuff, but that's not immediate. That is eventual. If it's asked how much money what's the maximum they can lend out over time? Multiplier. But it's not asking over time. It'd be better if the question said initially. I'd always like it if they did. But they don't always phrase things in ways that are easy to understand every single time. They're not always consistent. It's a bit annoying, but I'm trying to prepare you for the worst case scenario. And in this problem, even if it didn't say initially, I would still interpret this as how much money can they lend out? $600. Hello, here's our thing. Here is where the word problem can really trip people up. What is the initial change, keyword there, initial versus maximum over time, on the M1 version of the money supply based on her withdrawal, and explain it. Okay. So let's make sure we understand what M1 is first. This is from our note, the first set of notes for this unit, which is the money assets interest rates notes. M1 is what most people refer to as the money supply. It does not mean necessarily cash, although it does include it. It means spendable money, money that people can access and spend. Comes in there's three things that make it up. You have currency in circulation, so cash, can't spell currency, aka cash and coins, but let's say cash. And it includes deposits, like money in a checking account. And it includes savings account. Short-term savings, to be clear. This is like a standard savings account, not like a high-yield savings account or like an investment-style account or a money market account. This is just like you have a standard savings account. So it's these three things combined is your M1. I'm going to rewrite this so you don't read this as a subtraction symbol. Oh, good God, no. Hate pushing that key. There we go. That's what your M1 is. It's the total of those three things combined. So let me walk you through this problem. It's not as complicated as it sounds. The answer is actually very simple. Wanda goes up to her bank, withdraws, what is it, $500. Cool. So she had $500 that was deposited there. She now takes it out of her bank. Cool. So it's $500 less in deposits, which makes people think, oh, so M1's gone down by 500. No. She has $500 more in cash. So it's $500 more in the money supply. No, also no. M1 is this plus this. Plus this is, which isn't even in the question. So I'm ignoring this last thing because it's not even in this table at all. So I'm just going to goodbye that. Okay, I'm going to ignore that for now. There's $500 less of deposits. So there's, I'll just like write it below it. Yeah, okay. It's going to get very confusing very fast. Deposits, we go, I'll put it in brackets. There's 500 less in deposits, but she took it out of her bank. What does the bank give her in exchange for that deposit? $500 in cash. Currency in circulation means it's not being stored in the bank. It's out there in people's pockets, flowing around in the economy. Meaning M1 did not change. Total value anyway. The total value of M1 did not change. The composition of it did, in terms of which part of M1 is this in, but M1 is just this plus this plus this. I moved the 500 from one thing to the other, but it's still in M1. So there's no change to M1's value at all here. Now, if you were to say the bank uses some of its excess reserves to purchase a bond from the Federal Reserve or from the Treasury, cool. Then we're talking about M1 actually being changed, because $500 that was in M1 before, in deposits or in currency, is now no longer there. It is now in the hands of the Federal Reserve, which it's not in M1. M1 does not include money that the Fed is holding on to. M1 includes money that is accessible and spendable for the general population, which includes your cash, your deposits, and your short-term savings account. That's all spendable money for people. So there's no change to the total value of M1 there. Be careful. If you're seeing M1 being asked about, they love this kind of trick question because of the word initial change. Now it says money supply, so you're like, why don't I do the multiplier stuff? Initial. Initial change is the key word. Multipliers take place over time. It's asking initially, it's asking, hey, she withdrew that money, what happened to M1 just now? Just nothing else has happened yet. She withdrew $500, what happened to M1? Nothing happened to M1. Cash in my pocket and cash in my bank account are both a part of M1. I moved the money from one bucket to another, but the two buckets are part of M1. So how much money is in M1? I just moved things around, but it's still the same amount of money. Always tricky. They love asking about this. Almost every, but 75% of balance sheet FRQs have a question like this on there because kids get tripped up on it so much. So very standard. Okay, next one. The following is a bank balance sheet for the Bank of Asgard. Yes, I was in a Marvel kick when I was making this one. I don't remember which movie had come out at this point. Might have been Endgame, I think. So when I created this practice a while back. Yeah, so this practice is a little old. But the questions still work. We've got a more complicated balance sheet, gross. We've got 10,000 in required reserves. We've got 200,000 in checkable deposits. That's the same thing as demand deposits. That's just money in your checking account. I have $65,000 of excess reserves, gross, $125,000 of loans, neat, and $25,000 worth of treasury bonds. These are the bonds from the federal government. This is how the government borrows money, and most of the money the government borrows comes from banks. So here we go. Seems like Asgard's central bank is having to borrow money here. I guess they're not doing so great. It's all the gold palaces and stuff. You also have $25,000 of owner's equity. Again, I'm going to remind you guys, that's just money the owner of the bank has put into the bank as kind of an investment. It's not money the bank has to necessarily pay back, although the owner does want their investment back at some point, which is why it's a liability. But what I'm telling you is it's not a deposit. That's the important categorization here. It is not a deposit, which matters for this very first question here. What is the reserve requirement? Again, the reserve requirement is the percentage of deposits the bank has to hold on to. So I'm just reading this first line here. They love opening with this question on a balance sheet. They love doing it. It's not every time, but it's a classic because it's a very easy question to ask at the start of the FRQ with a balance sheet, which there are a good number of. So what's the reserve requirement? Okay, 10,000 over 200,000. This is just me showing my work. So 10,000 over 200,000 is, if I cross out a whole bunch of zeros, 1/20th, which, thank you, is 0.05 or 5%. Be careful with 0.05 versus 0.5. 0.5 is 50%, 0.05 is 5%. Careful with decimal places. 1 over 20 should be half of 1 over 10. 1/10 is 10%. 1/20th is 5%. This logic really is just how many nickels go into a dollar? 20. 20, if a nickel is 5 cents or 5% of a dollar, you need 20 of those to hit 100. Yeah, so 5% is our reserve requirement here. My brain does really well with ratios, if you're wondering. That's the math skill I always had a pretty good handle on. I'm not the smartest guy in math, but ratios can get you through a lot of things, especially even in calculus. I could get through a lot of it with ratios and just sort of like matching numbers, pattern brain, basically. That part my brain has a pretty good handle on. Okay, how much money can currently be loaned out? Hello, key phrase. How much money can currently be loaned out? Okay, pause, see if you can figure this one out. This is not really a math problem. Unpause. Again, this money had been loaned out. That money gone. The bonds, money's technically been loaned out to the government, but also it gone. It's not money. They can't loan out the bond again. They can sell it to somebody else, but that's not them loaning it. That's them transferring the debt. Here is our loanable funds right here, our excess reserves, 65,000. That is it. If they ask you to explain it, it's because excess reserves refers to money that banks can loan out. So $65,000 is how much money the bank can loan out currently. Maximum change over time would be multiplier stuff. Hey, look at that. If the bank were to loan out all of their excess reserves, and thank you, what is the maximum amount the money supply could change by? Got it. Max amount the money supply could change by? Yeah, I can do that one real quick. So we're talking excess reserves is 65,000. Don't love the number. Times my money multiplier, which is 1 over 0.05. For the love of God, be careful there. So many kids write 0.5 in that. Seen it every time. And that gets me what? 1 over 0.05 is 20. 65,000 times 20 is going to be a fairly large number. I want to say 1,300,000. Let me confirm that real quick. I believe that's right. 65,000 times 20. Yeah, 1.3 mil. Which, if that's too big of a number, it's like, no, it's not. 65,000 is a lot of money times 20. Like 50,000 times 20 is $1 million. So yes, this is correct. 1.3 million is right. Now, banks can create a lot of money. Like, we were using small numbers before, but a real bank account does not have like, a real bank doesn't have like $3,000 in it. It has millions of dollars in it. So them being able to create money like this is huge in terms of their impact. Okay, assume Loki, deposits $20,000 in the Bank of Asgard, completes the new balance sheet based on Loki's newly added deposit. Okay. So basically, they've given me a balance sheet that's sort of blank. Some things have been left alone in case kids got confused, but the rest of this is very much solvable. So we know we're going to basically take these numbers here and then add this 20,000 to it. This is the balance sheet previously. It's asking, okay, Loki deposits 20,000. What happens to the balance sheet after that deposit happens? Okay. So first thing I know, very easiest part, the deposits would change. He deposited 20,000, so I've got to add 20,000 what they had there before. So this should be $220,000 now. That's what I'm looking at. So $220,000 of checkable deposits. Cool. This loan number is next. The reason why this loan number is next is it doesn't say they've done anything with the money yet. It doesn't specify that, and they've loaned out, blah, 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 blah. They haven't changed loans at all here. Nothing has been loaned out yet. This should still be 125,000. Unless the question told me what they were doing with Loki's money, none of the other assets outside of those first two would I ever mess with. If they said, and they loaned out 5,000 of it, then I'd be like, okay, let's add 5,000 to loans and figure some stuff out. Okay. And this is where the split logic happens. The $20,000 deposit, how much of that goes to the required reserves and how much of that goes to the excess reserves? That's how we logic this out. So of that $20,000 deposit, I know that 5% of it, 1/20th, has to go to the required reserves. The nice part here is I gave you numbers that were easy. A 20th of 20 is 1,000. So I'm going to add 1,000 to the 10,000 that was already there. That's why this is 11,000, because 1,000 of that 20 the bank has to hold on to, and the remaining 19,000 of this $20,000 deposit gets added to the excess reserves, which were 65,000, and 65,000 plus 19,000 It's 84,000. Again, if you see a balance sheet like this, you're like, I think I have the answer. I'm not sure. How do I check? The two rules. This has to be the correct percentage of this. So this 11,000 would have to be 5% of 220,000. Quickly calculate. Let me show you. Calculator. How do I check that, Mr. McRitchie? Two ways. Either type 220,000 times 0.05, or you would do, what was the other way I would do this? I would do, 11,000 divided by 220,000, 0.05. Either way would work just fine. So you'd figure that out. So this is the completed balance sheet for this bank. I don't have to change either of these things because they haven't told me what they're doing with Loki's money. I'm not going to change the equity because that's not a deposit. That's money the owner of the bank put in separately. So that's not changed at all. So really, I'm just thinking of, okay, deposits go up by 20K because he deposited 20K. And I have to split that deposit into excess and required reserves. Technically, I think deposits are easier on a balance sheet than withdrawals. Withdrawals, you have to take the money out, adjust your required reserves, and then add that new leftover here. There's a lot happening there. Whereas with deposit, you're just like, okay, add it to the deposits, easy. Split that deposit into excess required. Okay, not too bad. All right, last one. A real FRQ. Straight up from an AP exam, you can find this thing on AP Classroom. You can look this bad boy up. This one is complicated. This is probably the hardest balance sheet question I've seen on an AP exam, only because they ask some weird things that haven't really been asked before, either in this practice or frankly in the course. I hadn't seen it prior to this AP exam question. It's not that it's impossible to figure out. It is just going to require you to do some logic. Okay. Now this one I can't just type, so I'm going to use these probably a comment box or a text box. Let's do text box. I don't like you, you stupid thing. This is mostly because I'm like an old man who still uses Microsoft Word a lot. I don't use Google as much as I probably should for things like this. Whatever. Okay. I'm going to use the drawing tool. Tell me there's a drawing tool on here. Oh, I've got one actually. I've got one I can use here. Not Epic Games Launcher. Please don't open Epic Games. Oh, thank God it didn't. Epic Pen is what I'm using. Hello, Pen. Okay. I don't care about this update. How big is this? Oh, that's probably too big. Okay. So we've got this balance sheet. It tells me reserves. Doesn't specify which. Irritating. Tells me loans. Okay. Tells me deposits, 2,000. Great. Equity, 0. Honestly, a pretty simple balance sheet, but there's one weird thing happening, which this. It's not specifying if those are required or if they're excess reserves. Mentally take a note of that. Okay, assume the reserve ratio is 10%. This is annoying. This should be a decimal. I don't like that they did this. Whatever. The ratio is 10%. Okay, so I know 10% of the deposits they have to hold on to. Oh, these are all required reserves. How do I know that? Well, I know 200 is 10% of 2,000. So they've told me this is just reserves, but I know, big brain, this is actually required reserves, which gives me a very important thing that I know, and it's the answer to the first question. What is the dollar value of new loans that they can make? How much new loans can they create? The word new here is to help you not put 1,800. Those aren't new. They've already loaned that money out. How much money can they loan out right now? The answer is $0. But what? What are their excess reserves? The money the bank can loan out is the excess reserves. There's currently none of those. They've got required reserves, $200. They've got loans, $1,800. That's all the deposits. They have no excess reserves. The explanation here, which I'm not going to write because I don't want to write it with this gross pen, but I'll say it right here. The explanation for this is because this bank has no excess reserves. The $200 of reserves is all required reserves, and this bank has loaned out every other dollar they could have. So there's no new loans this bank can now make. That's a very fancy explanation. If you said because they have no excess reserves, that would be sufficient. Mr. Smith deposits $100 of cash in a demand deposit account, just a regular checking account, in First Superior Bank. Calculate the maximum amount of new loans that they can now make. Careful, doesn't say over time. The word maximum there makes me want to do a multiplier thing, but it does say how much they can now make. Doesn't say over time yet. It just says max amount. How much money of that deposit could they loan out is what this question is asking. So I'm thinking, okay, this $100 gets split. 10% goes to the required reserves. So 10 goes to the required reserves. The remaining 90 goes to our excess reserves, and that's the loanable money for the bank. So hello, $90. If you drew a diagram like this, they would count that as sufficient work. If you wrote 100 times 0.9 equals 90, or 100 times 0.10 is 10, 100 minus 10 equals 90, all of that would work sufficiently for work showing. I think this, honestly, as a grader, I'd be like, yeah, you get it. You know what's happening here. So yeah, that's $90. C and D, the fun part. As a result of the $100 deposit, calculate the maximum change over time. Multiplier problems, 2 of them, weird, in each of the following in the banking system. So importantly mentioned, the multiplier doesn't have to happen in one bank because that money could get loaned out to you. You deposit in a different bank. Like it doesn't, that's why it's the banking system, because it could happen throughout a bunch of different banks. Usually that's how it would work. So that's normal. So as a result of the deposit, calculate the maximum change over time each of the following, meaning they're basing it off of this deposit because of this excess reserves number. Remember, the money multiplier formula was, or the multiplier for using it was change in excess reserves times money multiplier equals change in the money supply. So I would do this. This change in loans over time is the money supply change. That's technically a synonym here because the way they're creating money is money is getting deposited, lent out, now it's usable, spendable. Deposited, lent out, now usable, spendable. Deposited, lent out, now usable, spendable. So like maximum change in loans / money supply is actually the same thing. So I would just do the 90 as my excess reserves times my multiplier, which is 1 over 0.1, so 10, gives me $900 as the max change over time of loans. Okay. That's not new, although the word loans instead of money supply is a little new, but it's not new math here. C2, prior to this question, I had never seen a question like C2 on an AP exam. This is from, I think, the 2017, 2018 AP exam, maybe 2015. It's in that decade, there was a whole bunch of balance sheet problems, which is ironic if you know the history of how these balance sheets ended up going in real life. We'll talk about that later. Demand deposits. What? Let me reiterate how the multiplier effect works so you understand what this question is asking. Okay, the way the multiplier effect works was money gets deposited into the bank, gets loaned out to somebody. That person then deposits into their bank. It gets loaned out to somebody. It gets deposited, loaned out, deposited, loaned out. The bank is creating money because they're loaning out the same money multiple times over, but each person can spend that money. So there's a lot of like money that's not technically real, but is usable and spendable to people because the bank is liable for it. So it is real, which is a very funny, funky thing. But what's happening is money gets deposited, loaned out, deposited, loaned out, deposited, loaned out. The money supply changes based off of that loan money because that's actually how much money is going to get spent. But technically speaking, money is also getting deposited there too. So here's the logic that I think of for this problem. There's a formula I'll show you in a second that solves this very easily. But in my mind, I think of this number right here. What this tells me is banks could loan out $900 through the multiplier process, right? Okay. What other information do I know about loans in this economy? I know how much of deposits they can loan out, right? I got this $90, meaning I knew that of a $100 deposit, they could loan out 90. They can loan out 90% of deposits, right? Well, I know they have loaned out $900, and they're asking me how much has to have been deposited to make that happen. So they can loan out 90% of deposits, and they did loan out $900. How much money has to have been deposited so they could loan this out? The answer is 1,000. If $1,000 is deposited, they could loan out 900. That's like I'm like reverse engineering the math. There's a formula that makes this easier in case you're not that like if you don't like get math that level of like being able to like okay, so 900 was loaned out. They could only loan out 90% of deposits, so there had to have been $1,000 deposited for them to have loaned out 900. There's a formula though. And there's a shortcut for pretty much every multiplier problem. If you see maximum change over time of a thing, take the initial thing, multiply by multiplier. Maximum change in loans, how much can be loaned out, times the multiplier. Max change in deposits, take the change in deposits, which was Mr. Smith's $100 deposit, times the same money multiplier. Yep, same number. There you go. They do this so rarely, I don't teach this equation. It's only happened a couple of times, and I don't want you to memorize an equation that's only been used like twice. The logic would get you there. Some of my kids can solve it by doing that reverse engineer math logic. It's kind of hard to do that, to be honest. But if you did that, you would get 1,000. Or if you see a multiplier thing, max change over time equals multiplier thing, multiply the thing by the multiplier when in doubt, that'll probably work. And hilariously, if that has like maximum change in excess reserves, like take the excess reserves times the multiplier. Maximum change in required reserves. You're like, what? Take the required reserves times the multiplier. It would get you 100, which would also make sense mathematically here. So if you see max change over time, we're talking multiplier problem. Be aware of that. Okay. This D is just comedic. D is just a prank, I think, on students that like really get confused by things, and it's not their fault. This is just honestly stupid. D, as a result of her deposit, calculate the maximum change over time. Multiplier problem. In the money supply. If you're wondering, haven't we already done that? The answer is yes. It's this. Maximum change in the money supply was the change in loans. Such money was actually being created that was usable and spendable in the economy. So it's the excess reserves. Again, that was $90 of that deposit times your multiplier equals 900. I think this is just here as like a vocab question of like, do you know vocabulary? But I think it's kind of cruel. I don't like this question because what this means is on your AP exam, your answers were 0, 90, 900, 1,000, 900 again. If I was a kid taking this AP exam, I would have had an anxiety attack. I'd been like, one of these has to be wrong, or all three of these are wrong, or I'm going to explode. Like something weird is going to happen because I don't like two of my answers being the same thing with the same work. They just asked for the same question two different ways. They can do that. You just got to read the question carefully. If you see max change over time, it's a multiplier problem. Go from there. You know the formula for the change of the money supply? Cool. Honestly, D is easier than C because you have a direct formula for this. C1 requires you understanding that formula's vocabulary. C2 requires you understanding the next level of that formula, which is the implication of what happens to deposits. So honestly, in terms of difficulty, this question goes, A is easy. B should be very easy, even if you don't understand A. B should be very easy. D, E is pretty easy if you understand the concept. E is the last question. Provide one reason why the actual change in the money supply can be smaller than the max change you predicted in part D. Basically, why might not this happen? Why might this $900 not happen? If you know how the multiplier works, like what is happening in it, again, money gets deposited, loaned out, deposited, loaned out, deposited, loaned out, all the way down until there's no money left. There's a number of issues with that in terms of like logically, like will the bank be able to loan out all of that money? Probably not, because like at the end of that, you get to like numbers that are like, there's a $5 deposit and they can loan out $4.50. It's like, okay, I mean, who's taking a $4.50 loan for real? Like, so there's that. So one reason would be banks are not able to lend out very, very, very small amounts of money because people might not want to borrow very, very small amounts of money. Correct. Second, banks, are they required to loan out all of their excess reserves? No, the previous table we saw, they bought bonds with some of that money. So they can use that excess reserves for anything. This assumes they're loaning out all of their excess reserves every time. So if you say banks may not loan out all of their excess reserves, that's another reason why this might happen. Another issue is timing. It required money being deposited, loaned out, deposited, loaned out. If any of those people, instead of depositing it, kept it in the form of cash or kept any of it in the form of cash, like didn't put it back into their bank account, multiplier effect can't happen if the bank doesn't have the money. So if we get that person who takes like a $500 loan out, there's like, it's $500, I'll just take it in cash. The bank's like, no, please don't do this. We could loan it to somebody else. They get sad. But it also means the money supply change is not going to happen. So there's a bunch of reasons. Again, uh, banks might not be able to loan out all of that money because people might not want loans in such small number. I think the easiest one is banks, because it's the most true. Banks don't use all of their excess reserves for loans. They might use their excess reserves for other things, whether that be bonds, investments, assets, whatever, or just to have some in case people want to withdraw a bunch of money. They might just have some for that. There's a bunch of reasons why. There's a litany. I gave you a whole bunch. Any of them would work. Just one reason. Any of those would work just fine. Use any of those. Okay. Lot of explaining, lot of talking, lot of things happening. Let me go back to, oops, need my cursor back. Default. All right. That is the practice. This is a long video for sure because I went and actually fully explained every single problem, like fully through. You could solve this practice faster because you didn't have to teach it to anybody, so don't feel like this is actually an hour-long practice. It's, for most students, I would say it takes them about 40 minutes, which is a lot, but that's how long our class periods are, so it's kind of how long I want these to take you. If you got stuck on the balance sheet stuff, totally normal. The thing you need to understand for especially our test, multiple choice questions especially, know the money multiplier stuff. Know that, because on multiple choice questions, that's the majority of what they're asking. I would say make sure you will understand that M1 thing, the like, it being a cash or a deposit, like moving between those two things doesn't change M1 because they're already both in M1. Like I'll show you a visual of that in case you were not understanding that fully. M1, I have a whiteboard so I can show you with this. M1, this marker sucks. Of course it does. All my good markers are in my classroom. Are you good? You better be. Oh, thank God. It's at least better. Okay. M1 is comprised of three things. You have cash. You have deposits. And you have savings. Bad drawing, but you have cash, deposits, and savings. They're all in M1. Moving money between these three things does not change M1's total value. 500 less of deposits, and now it's in cash. M1's still the same. It's just in which of these three things is it in an M1 has changed, but the total amount of money in M1 hasn't changed. If you put money into your savings account, M1 doesn't change. I'll say it in a much more like rational way. If the money supply literally changed every time you withdrew or deposited money into your bank account, that would be insane. Because that means I could mess the money supply up by just being like going to my ATM and just taking money in and out and just like pranking the Federal Reserve by like messing the money supply up. So you withdrawing and depositing money does not change the money supply. Banks can change it by lending out your deposits eventually over time. So money being deposited is like can have more long-term effects on the money supply. But if there's that's what happens to M1 initially, as long as it's staying in those three categories, it's moving between those three dudes, nothing's happening to M1. If it's moving to other things, different assets going to the Federal Reserve, whatever, then M1 could be changing. But otherwise, it's not. Okay. I hope this video was helpful. I hope you guys understand what's happening here. If you have any further questions, feel free to leave them in the comment section below or email them to me if you're one of my students. But hope this helps you guys understand what's going on there. Appreciate it as always. And again, if you need a copy of this assignment, I'm going to put the copy of the assignment in the comments of this video or in the description of the video so you guys can actually access it. So thank you.